Now, the good news is that Mikhail is actually ahead of schedule. Thank you very much. And before he is getting into his presentation, I would like to properly introduce him. So let me see what we have here. Hold 1 second, Eric. So we have with us Michael Kosinski. He is the professor at Stanford University, and his research interests encompass both the human and artificial cognition. His current work centers on examining the psychological processes in large language models and leveraging artificial intelligence, machine learning, big data, and computational techniques to model and predict human behavior. Now, Mikhail has co-authored Modern Psychometrics. It's a popular textbook, I highly recommend to read, and published over 90 peer-reviewed papers in leading journalists that have been cited over literally 20,000 times. He's among the top 1% of the highly cited researchers according to Clarivate. His research inspired a cover of literally The Economist. And this is amazing, in 2014, the theater play Privacy as well. So multiple TED Talks he has done, video games, and was discussed in thousands of books, press articles, podcasts, and documentaries. Mikhail was behind the first press article warning against, we know the name by now, Cambridge Analytica. His research exposed the privacy risks that they have exploited and measured the efficiency of their methods. Now, that is a big compliment of what he has accomplished there. Without any further ado, I'd like to welcome Mikhail to the stage. Mikhail, the stage is yours, and thank you very, very much for joining us today for the summit. Please go ahead.
Thomas, thank you so much for your introduction. Thank you, folks in the audience, for being here. I will use my allotted time to tell you more about my research into privacy risks, and how governments and companies are leveraging our data to our benefit sometimes, but also to our detriment. So as you very well know, we're leaving behind an enormous amount of digital footprints when using digital products and services, ranging from smartphones to online social media platforms such as Facebook or Twitter. Now, those are huge amounts of data. 400 million photos are shared on Facebook and Instagram alone every single day. 500 million tweets, 65 billion messages on WhatsApp are exchanged every single day. 5 billion searches on Google alone. 320 billion emails are being sent and received every single day. Our wearable devices, such as smartwatches that monitor our heartbeat, our temperature, our geographical location, our mood, our voice, our interactions with other people, moments when you come close to other people wearing other devices, gather 28 petabytes of data, again, every single day. Now, this data has enormous market value. It has been estimated that this year, this is around $200 billion every day is being paid for data generated by those platforms and devices. And this value is growing at about 10 to 20% every single year. So very soon we'll see much larger amounts of money exchanged in return for the data that we're generating while using digital products and services. Now, this is not just my opinion. Here you can see the cover of The Economist back from 2017, so over 6 years ago now, where The Economist essentially touted big data as the world's most valuable resource. And you can see here on this cover, bunch of companies that were explicitly set up around the idea of harvesting, generating big data, such as Google, Facebook, Microsoft, who joined the game of collecting big data a bit later, but now is very well established in this space. But when you look around, you realize that even companies in much more conventional industries, industries that predate the era of big data, are really quickly realizing that this is indeed the most valuable resource. Credit card companies. Most of folks in the audience have a credit card. Most of us do not really pay for using this wonderful device that makes our lives so much easier and safer. And this is because the cost of running those networks is paid in part by the vendors who have to share with the credit card operator a little fee each time you buy something, but increasingly because those companies are collecting, harvesting, and then selling data generated by people who use those credit cards. And as you can expect, the bigger the spender you are, the higher salary you have, the more valuable your data is going to be on the market. Now, even products and companies on very traditional markets, such as automotive industry, is very quickly racing towards harvesting and collecting their users' data. If you're lucky enough to have a Tesla, your car is going to be fitted with enormous number of sensors monitoring your behavior of your car, where you're driving, how are you driving there, but also the surroundings, collecting data about the road condition, about what's happening around, about the traffic, but also about cars around you. Now, this data has enormous value. Recently, it has been estimated that the market for vehicle-gathered data very soon in 2030 is going to reach $750 billion. And this excludes the value of this data in the context of building self-driving vehicles. Because as you'll quickly figure out if you know anything about the automotive industry, that's the holy grail here. And the data generated by people driving those cars using autopilot or without autopilot, correcting the autopilot, is collected and processed in order to teach the machine how to drive the car on its own. Now, whoever gets there first will reap enormous benefits. All right, so what kind of insights can be gleaned from those digital footprints that are collected from us? Why would anybody pay for my clicks, my tweets, my status updates, the history collected from my smartwatch or from the car? Well, I mentioned two applications. I mentioned the fact that you can train the self-driving car using data collected from the drivers. You can also sell this data to marketers in order to facilitate targeting you with ads and product offers. But it turns out that the applications are much broader. One of the aspects of this data that's particularly interesting to me, I'm a psychologist and computer scientist by training, is that you can use big data that we are generating to create very precise psychodemographic profiles of individuals. You can essentially understand not only where they are coming from and who they are, demographically speaking, such as predict your socioeconomic status, but also understand your intimate psychological traits. And let me show you here a short video documenting one of our studies that we've conducted in order to better understand what's possible. This is now a 10-year-old study, and yet the result stands the test of time very well. They're very representative of what's possible today. In this study, we collected data from 60,000 Facebook users. Each of those users shared with us their Facebook likes, which are very generic types of digital footprints. And we also collected psychodemographic data. Those folks filled in questionnaires for us, personality questionnaire, intelligence questionnaire, and a bunch of other measures. And let me show you a little video here illustrating the findings of this study.
Ian, we're very sorry, but we don't hear the audio to the video, just the video itself.
All right, I hear the reports that there's no sound. That's a shame. Let me see if I can reshare my screen. It would work really well for me if I could share sound. All right. Sorry for this, folks, and please correct me if the sound is still not there.
Now, clicking like on Facebook is something most of us do without thinking.
The University of Cambridge over in London actually did a study
of what people like on Facebook to try to determine facts about them that they wouldn't otherwise know. So they didn't just look at the products, the movies, the bands that people like. They also looked at the status updates that people liked, the photos that people liked, and they were able to draw some really, really interesting conclusions about
all of your likes that you're clicking can tell more about you than you might have realized, from your political values to your religion to your gender to your happiness to your age.
In fact, some parts of your identity can be predicted with 95% accuracy.
Accuracy was lowest, about 60%, when it came to predicting whether a user's parents were still together when they were 21. People whose parents divorced before they were 21 tended to like statements about relationships. Drug users were ID'd with about 65% accuracy, smokers with 73%, and drinkers with 70%. Sexual orientation was also easier to distinguish among men, 88% right there. For women, it was about 75%. Gender, by the way, race, religion, and political views were predicted with high accuracy as well. For instance, white versus black, 95%.
The findings have alarmed privacy campaigners who fear this research could be used to commercially exploit users.
So keep in mind that just because you think you're not revealing a lot of personal details on Facebook, you're still spreading the word to the outside world as well as those online marketers.
Volunteers with few friends liked walking with your friend and randomly pushing them into someone or something. Hey, it's not their fault they don't have friends. Everyone they know keeps getting randomly pushed into traffic. High IQ corresponds to liking Mozart, science, and the Colbert Report.
Research indicated people who like Harley-Davidson motorbikes are generally of low IQ. We thought we'd better offer a right to reply.
I'd say our average customer is probably more intelligent than most, and we've certainly got a lot of customers who are, well, people from Cambridge University for a start.
A like on Facebook can reveal if you're a gay man. Yeah, especially if what you choose to like is penises. That's apparently true. That's my wife walking in. I'm like, oh, it's a joke.
Okay. By the way, don't be an idiot and think that if somebody clicked on Wicked the Musical that they're gay automatically, or they clicked on Harley Davidson and they're stupid automatically. Ironically, that would make you stupid.
All right. So as you folks could see, those seemingly innocent types of digital footprints, Facebook likes, allow revealing a very broad range of intimate traits of individuals. And that can be done at a very high speed, very low cost for huge populations. So now let us ask the question, okay, so how does it work? How is it possible that those predictions can be made? So I have this little equation here that will clarify this issue. But before we jump into analyzing this equation, Let's look at one practical example. Imagine you have an anonymous Facebook user. You know nothing about them apart from the fact that they liked Hello Kitty, the brand, on Facebook. Now, is the gender and age? What is the expected gender and age of this person? Now, if you thought that those were young women, well, you're very judgmental. It turns out that the biggest fan of Hello Kitty is this retired policeman from Japan. You'll be judgmental, but you'll also be very accurate. It turns out that 99% of people who liked Hello Kitty on Facebook are women, and most of them are in those younger age groups. Meaning, if you know nothing about the person, apart from the fact that they liked Hello Kitty, you'd be very accurate if you predicted that they were young women. Now, of course, you can make a broader range of predictions. Would this Hello Kitty fan work in the military or in sales? Well, if you guess sales, you'll be right. Hello Kitty fans are heavily overrepresented there and underrepresented among people working in the military. What about what kind of device they're using? Are they using a PC or maybe an iPhone? Well, of course, they're using an iPhone. They probably don't, they haven't even seen a PC, a traditional PC in their relatively short lives. So what I'm showing here is that you don't even need to be a computer algorithm. You don't need to be a data scientist. Every one of us can make fairly accurate judgments based on even individual digital footprints. Now, of course, in the real world of digital footprints, those footprints are on average much less revealing than Hello Kitty. Hello Kitty is an extreme like that has a very biased, skewed audience. Most other digital footprints, such as liking or watching or talking about Tom Hanks and his role in Forrest Gump, the movie, liking the Forrest Gump, is not as revealing about your intimate traits. Everybody likes this movie. It's just an amazing movie. But when you look closer at the data, those are just statistics pulled out from Facebook marketing platform, you can see that even here, the statistics are not equal. You can see that men, and especially older men, are overrepresented among people who liked that movie, meaning that if you know nothing about the user, just that they liked Forrest Gump, you can update your beliefs about their gender and say, well, I still don't know their gender, but it's slightly more likely that they are an older male. Now, the huge advantage that algorithms have over us is that they can very easily look at hundreds, thousands, or tens of thousands of digital footprints that we all leave behind every single day while using those digital products and services. And from each one of these digital footprints, extract this little tiny bit of information that on its own, maybe, is not that significant. But if you aggregate it over thousands or tens of thousands of Facebook likes, suddenly a very precise and accurate psychodemographic profile of an individual emerges from it. So the question here is, okay, so how accurate are those accurate profiles? Well, let me show you some examples of predictions that can be made based on Facebook likes alone. And let's keep in mind that Facebook likes are not the most revealing types of digital footprint. Facebook likes happen in the public space. We know that what we like is seen by others. We very often do it strategically just to, maybe project some particular image. There are many other digital footprints that are way more honest and way more revealing than Facebook likes. But even Facebook likes, it turns out, can be extremely revealing. You can use Facebook likes to reveal traits such as religiosity, political orientation, sexual orientation, gender, ethnicity. You can even predict with some accuracy, it's not that high, but you can even reveal with some accuracy whether someone's parents got a divorce, or whether a person uses drugs, or whether they're single or in the relationship. Now, you can go deeper than that. Those were mostly demographic traits. You can look at people's psychological profiles. What you will see here is a plot mapping the number of Facebook likes that we can record from someone's profile versus the accuracy of predicting their personality. We use the Big Five personality model here, but one can use other models. You can see that the more Facebook likes we extract from someone's profile, the more accurate are those predictions. Now, how accurate? What does it mean? The accuracy expresses the correlation is about 0.6, 0.7 for those personality traits. Well, let me illustrate this accuracy by comparing the accuracy based on Facebook likes, or predictions based on Facebook likes, with accuracy derived from a different type of prediction model. Imagine that instead of using Facebook likes to predict your personality, we went out and asked your work colleagues to judge your personality, to fill in a personality questionnaire in your name based on their knowledge and their interactions with you. Well, we spend quite a few hours every week with our work colleagues. They know us pretty well, and this is why they can predict with quite some accuracy our personality traits. Now, how does it compare with Facebook likes? Well, it turns out that you need about 10 Facebook likes from someone's profile to predict their personality with the same accuracy as can be achieved by their work colleagues. Now, friends, cohabitants, family members know you even better. But even here, you need around 90 to 100 Facebook likes to match their accuracy of prediction. And now, the most accurate of the judges of your personality, your spouse, can be outperformed with a model using around 250 Facebook likes. Now, 250 digital footprints, that's not much. We leave thousands, if not hundreds of thousands of digital footprints every single day. And yet it turns out that a very simple prediction model, linear regression or logistic regression, can predict your personality with the same accuracy based on those 250, 300 Facebook likes as the person that knows you the best. As the person, as some studies suggest, knows you better in some ways than you know yourself. Now, this plot, I think, very well illustrates one of the most important insights of big data research, that the data visible on the surface is just the tip of an iceberg. That when you use predictive algorithms, when you use machine learning, when you use artificial intelligence to process this data, to make predictions about an individual, you can extract enormous amount of additional data from those seemingly innocent and seemingly simple digital footprints. Now, do you find those findings surprising? Are you surprised by the accuracy of the algorithms? Well, I certainly was surprised by the accuracy of the algorithms, but then I realized, hey, it's not really new. We've been surrounded by algorithms making very accurate decisions for quite some time in trading of equities, futures, options, and so on. Algorithmic trading, algorithms have been replacing human traders for quite some time. And in many of those markets, majority of trades are executed by the machines because machines are better than human traders at making those predictions. And even in my own field, in psychology, the agreement, consensus seems to be that mechanical prediction will always outperform the clinical diagnosis. So even when predicting those most psychological, most intimate, most humane traits of us humans, such as personality traits or our propensity to suffer from a particular psychological disorder, even here, machines outperform humans with quite some ease. Let me show you one study from this book, from Paul Mills' book, where he looked at a group of 29 psychiatrists and those psychiatrists were given the admission documents of people that were admitted to a psychiatric hospital. And some of these people were known to have to be hospitalized for a long time. They suffered from serious psychological and psychiatric disorders. Some people were just spent there a few days and being monitored, and it turned out that everything was all right. But you can look at admission documents and you can study how accurate those psychiatrists would be between distinguishing between those groups. A role of a psychiatrist, one of the roles of a psychiatrist, is to diagnose psychiatric disorder. Look at the history of the patient, look at the questionnaires that those patients are filling in while being checked into the hospital, and decide whether this person needs treatment or whether they should be released back home. So let's look at the accuracies. The average psychiatrist's accuracy was 62%. The best psychiatrists in this group had an accuracy of 67%. Now, it turns out that if you use an algorithm to make those predictions, this algorithm had an accuracy of 70%. This algorithm was better than the best of the psychiatrists. And this algorithm, by the way, was trained on the predictions of those psychiatrists. So this algorithm didn't have any additional knowledge. It was just observing the choices of human psychiatrists and then making its own predictions. And by removing the noise, removing fatigue, removing decision-making biases that humans have, it was able to outperform the teachers, outperform the very people on whose decision this algorithm was trained. Okay, so now I have a question to you. Can you guess what is the date of publication of this book containing this research? Now, I cannot see chat here, but I bet that you're guessing that those are, 1990s or maybe 2000 or maybe 2015. Folks, the date of publication of this research is 1954. That's the time where the supercomputer was IBM 650 with 35 kilobytes of memory. And yet at that time, it was already clear to psychologists that a computer is going to be always more accurate at predicting individual traits. And by the way, they didn't even use a computer. The algorithm that they were using was a simple equation. Look, a score on dimension 1 plus score on questionnaire dimension 2 and 3 minus score on dimension 4. And if the number was larger than 45, a person would be diagnosed with a disorder. If it was below, they would be released home. And yet accuracy of this algorithm was already better than whatever human could achieve. All right, so what types of data can be used in those predictions? I mentioned before Facebook likes. I mentioned data from admission documents to psychiatric hospitals, to some questionnaire data and maybe disorder history. You can use history of geographical location by looking at just 1 day worth of life of a person. Both a human and a computer can extract a lot of information. Affluence, profession, religiosity. Did they go to church on Sunday or where did they go on Saturday? Whom they are hanging out with. You can overlay this map with maps of other people and then figure out which people are connected with each other. You can look at people's history of media consumption, from songs to videos, and it turns out that this is extremely revealing about their intimate psychological traits. You can listen to people going about their life in their private spaces or at work, read people's emails. Here's a screenshot from one of our studies where we looked at how predictive of personality are people's status updates from Facebook, the language used in status updates on Facebook. And you can see here word clouds representing high openness to experience and low openness to experience extremes of those prediction models. And this, of course, is not just happening in people's labs. Here you can see a screenshot from IBM's Watson personality prediction engine, which you can feed with samples of text, both your own essays, but also maybe essays of your customers, or maybe of the essays of your political opponents or people you are collecting intelligence on. And without any privacy protections, this machine will give you a very precise psychological profile of this target. Now, more recently, I got interested in yet another type of digital footprint that we are leaving behind. Digital images of people in physical spaces. We are increasingly surrounded by CCTV cameras monitoring our whereabouts. We are uploading enormous amount of photos to online platforms and services such as Google Photos, but also profile images. So just images of our faces. Now, profile images or of pictures of faces captured by CCTV cameras, be it on the border, national borders, or in public spaces, are particularly interesting because human faces are really robust sources of data about individuals. Now, let me give you an example. Take a look at this man. Can you tell anything about him just by looking at his face? Well, you can surely say that he's spending a lot of time in the sun, playing golf, perhaps, but you can also judge gender, age, ethnicity of this person. Now, you can also tell the emotion of Donald Trump, even when he's trying to hide it. Now, those judgments are so natural, instant, instinctive, and accurate that we barely even notice we're making them. We're interacting with people, we immediately know the gender, we immediately know what emotion they're experiencing, yet without really thinking, hey, you learned all of this by simply looking at their face. And of course, CCTV cameras and algorithms analyzing those pictures can make exactly the same predictions. But could it be that those algorithms can go further? Could it be that algorithms, by simply looking at your face, can also tell your character? Can an algorithm say that this is an extremely stable genius by simply looking at his face? Well, our ancestors generally believed that this was possible. Darwin nearly didn't get on his voyage because Robert Fitzroy, the captain of the Beagle, was convinced that his face revealed his lack of energy and determination, and just couldn't find anybody else to replace him. So this is how Darwin got on the ship. And Fitzroy was in a good company. Aristotle was a big proponent of predicting people characters from their faces. Pythagoras was selecting his students based on their facial appearance. Now, today, luckily, such ideas are dismissed as silly. That someone looks like a pig does not automatically mean that they are as intelligent or as good as one. Yet, and this came as a huge surprise to me, as I was conventionally trained psychologist without being exposed to this type of research, it turns out that modern day research consistently shows that people can, with some minimal accuracy, judge others' characters from their face. Now, political views, for example. Political views are a character trait. Now, which of these men would vote for Trump? Well, this is a trick question, and you would always be right because both of them probably would do. But in psychological studies, we use more reasonable setups. So we would take one person that almost certainly voted for Trump and one person that almost certainly didn't, and then ask people to distinguish between those two. And it turns out that humans can judge it with consistently above chance accuracy. Those judgments are not very accurate, but they're consistently better at chance. And moreover, similar results have been obtained for a broad range of other character traits, such as personality, intelligence, honesty, religiosity, or even sexual orientation. So a broad range of psychological traits people can predict with some minimal accuracy from others' faces. Now, as we discussed before, computer algorithms seem to outperform humans at making those decisions and making those predictions. So if humans can do it with small accuracy, but still, is it possible that computer algorithms can predict character traits from people's faces with even higher accuracy? Well, that would be a serious privacy risk. So we decided to investigate. Now we are surrounded with facial recognition algorithms that look at our faces and analyze our faces. Your smartphone has one built in, and you're using it to unlock your screen. So what we decided to do, we decided to see whether those facial recognition algorithms, or more precisely, whether the vectors that those facial recognition algorithms extract from people's faces, whether those vectors encode or include information about people's political traits in this case. So we would give an algorithm a task. We would show two pictures of a conservative person and liberal person, and then ask the algorithm to extract those facial recognition vectors, and then would use essentially simple statistical procedure to see whether it could accurately distinguish between liberals and conservatives. And it turns out that, as in many other predictive contexts, those algorithms were much more accurate than humans. An accuracy of an simple AI-based facial recognition algorithm when predicting your political orientation from your face reaches around 70%, way higher than humans. And now those results were replicated across countries. So we had the US, we had Canada, we had the UK, across different environments. We had Facebook, we had photos from a dating website. And this works also when you control for demographics. Of course, your gender, your age, your ethnicity reveal your political views. But it turns out that even if you control for these variables, you compare, let's say, two women or two men of the same age and same ethnicity, the model is still able to make fairly accurate predictions. Now, how do those models make those predictions? So, of course, some of the signal surely comes from self-presentation. There are differences in how people decide to trim their beard or use makeup, or how do they comb their hair, depending on their cultural situation, or the cultural background, or the socioeconomic status and political views. So there's certainly some signal there. But the question was, okay, but what if people wanted to hide their political orientation? What if they, shaved, remove all of the makeup? What if they hide their hair? What if they all face camera directly? What if they don't make any facial expressions? Could it be that the picture of a neutral face with all of those external factors removed, could it be that we could then protect people's privacy? Well, we decided to answer this question by taking those standardized facial images where we removed all of the self-presentation from them. We had people shave, remove their makeup, face the camera directly. We hid their hair, we hid their outfits, we cropped the image tightly around their face and repeated the procedure. And it turns out that in the same task, AI achieves even higher performance. It turns out that the fact that those pictures were highly standardized and of very high quality enabled those models to make even more accurate predictions. So folks, what I'm trying to show you here is that even if you remove your Facebook likes from the internet, even if you stop using your credit card, even if you never post anything on Twitter, even if you stop using email, even if you essentially remove all of those obvious types of digital footprints, if you throw away your smartphone, hey, even then, your face is going to appear in those digital spaces. You're going to leave behind digital footprints simply because you just walk through public spaces or want to cross the border or want to get a passport and hence make a picture of yourself. And even this type of data, when combined with modern advanced algorithms allows revealing your most intimate traits, such as political orientation or personality. Now, what to do with this problem? What to do with those obvious risks to our privacy? Well, some people would say, hey, let's just work on privacy protection rules and policies. Let's have our politicians enact laws that protect our privacy. And I'm a big supporter of that. We should do all of this. But let's not forget that a motivated third party or a motivated insider can leak even the most well-protected data. There are many organizations and institutions out there very highly motivated to get their hands on this data. They are software engineers being kicked out from work that walk out with the USB drive containing a database. There are markets there where user data is washed or laundered, like in the context of money laundering, and resold as data collected legally. There are intelligence agencies that steal and republish or share intimate data of millions and billions of individuals. So even the best law, even the best privacy protection rules and policies will not guarantee that your data is not going to be available out there. Now, even more importantly, a lot of our technology depends on us sharing our data. Imagine using Google Maps without sharing your location. First of all, it would be just very difficult for Google Maps to help you navigate from point A to B without knowing your location. But also, even if you manage to do this, you'd be literally free riding on the backs of all of those other people that shared their data with Google Maps and hence enabled this product to exist, enabled this product to know where there is a traffic jam, enabled this product to know how to drive most quickly from point A to point B. So effectively protecting our data would also be a death sentence to an enormous range of extremely useful technologies that we all depend on. Not to mention that even if we did this, even if we said, okay, maybe it's just not worth having Google Maps so we can better protect our privacy, even then, it seems that most of us are really keen and eager to share our private data in an open space. Think about Twitter users, Instagram users. Think about people writing blogs and discussing stuff in public spaces. And you know what? People should be allowed and able to do that without worrying that their privacy is going to be invaded. So what? Ask some people. Okay, my privacy is going to be invaded. I will get some ads that maybe I don't want to get. Maybe they will sell me something. Who cares? Maybe we should move on. Now, well, if you're not asleep for the last decade, you know that your data can be used for much more nefarious purposes than just selling you some products that you don't need. As Cambridge Analytica example illustrates, big data, your digital footprints, predictions based on this data can be used to manipulate your propensity to vote for a particular candidate. Now, Cambridge Analytica luckily stirred so much drama out there that people started paying attention. People started paying so much attention that Mark Zuckerberg even had to put a suit on and fly to another coast to testify in front of our lawmakers about what happened. And Mark Zuckerberg was very surprised. He said, I just didn't know. I couldn't believe that, you can make any predictions based on people's digital footprints when it comes to their psychological traits and their future behavior. Completely forgetting that this is precisely Facebook's business model. Facebook uses your digital footprints and your behavior on the platform in order to understand you better and then target you with advertising and also target you with interesting stories and content that keep you engaged. So this is precisely the business model of Facebook, not to mention that Facebook has patented the very method that was later used by Cambridge Analytica. Look at the date here, 2012, well before Cambridge Analytica folks even graduated from high school. Facebook patented a method for determining users' personality from social networking system communication and characteristics, a method later used by Cambridge Analytica. And it's not only that, it's not only personality. Look at those two average pictures here. Each of those average pictures contains 100 males, male pictures that were averaged into one. Now, those two groups of males differ on an important psychodemographic characteristic. Now, think about it for a second. Can you guess what is the difference between those two groups of males? Well, they differ in terms of sexual orientation. And you can see that those average faces are very different here, just because there's 100 of them, and averaging 100 faces brings forward, amplifies even small, tiny differences between faces of individuals. And it turns out that facial recognition algorithms can reveal existing facial recognition algorithms. The one that is in your phone can distinguish your sexual orientation with accuracy of over 92%. That's, folks, extremely close to perfect accuracy. Now, when you combine this with this map showing where the government is going to harm you or kill you if they discover that you are gay, and if you realize that even in those other countries where there may be no legal persecution, it's often extremely dangerous to be outed against your own will. I'm sorry, Thomas, I was interrupted. Should I stop? Anyway, I will just go on because I've lost 2 slides. You should realize that those algorithms are extremely dangerous. And you can see that companies are doing it. Here you have a patent from 2012. It's around the same time when Facebook patented a method for using Facebook likes to predict personality. You can see a startup patenting a method for predicting psychological traits from facial images. And it's not just facial images. I showed you before a plot showing that you can use Facebook likes to make equally accurate predictions of people's sexuality traits, sexuality and other intimate traits. So let me just conclude this talk with the following statement. Look, folks, I'm all for regulation protecting our privacy. I'm all for implementing technologies that help us stay anonymous and our data hidden and under our control. But this doesn't mean that breaches of privacy will not happen. In other words, we can all agree that tornadoes should be illegal and we should just outlaw them. And yet, even the most well-meaning regulation of this kind will not stop tornadoes from coming. So apart from working hard to make internet and other spaces more private, we should also start thinking hard now how to make sure that even when those breaches are happening, even when those tornadoes are coming, our societies, our minorities still can have happy, safe, and secure lives. And I should stop here and release the floor back to Thomas.
Michal, I am beyond speechless. First of all, thank you very much for joining us here this morning. I am so glad, in behalf of all of us, that we did not, move you off the panel because you couldn't do it yesterday. This is very AI related. But here's my takeaway, and we will take a few questions in a second. I can almost predict for myself that when I go to sleep tonight, I will literally think about this talk for the rest of the day. The reason is I like to consider myself an optimist. And I'm always preaching and like to encourage startup individuals to look for the opportunities. But this speech, and I will promise you, we will make everything we can that this thing is going viral. The knowledge that you just shared, it feels like a damper. It's like scarcity, like beyond I could have ever imagined. But at the same time, it is the reality of the world that we are living in, and we are all part of it. I am absolutely speechless what I just learned about, and I didn't know this, that Facebook was actually able to not only submit the patent for what you just explained, they actually, I assume they got it granted. For me, that is, I have to think about this twice. So I am glad we put this in the program. There is obviously two sides of all this hype that we have on the applied AI for the enterprise, or also ChatGPT for the consumer. But the two things that we need to re-emphasize over and over again is the privacy in itself, what you just outlined, as well as the data protection and the European Act and all of that around AI. So I cannot thank you enough what you just shared. And I hope that many, many entrepreneurs and individuals and users, we all have mobile phones, we all have likes and LinkedIn's and Facebook's and social media, need to listen to what you just said. So I leave it with that. On the positive, again, there's always something coming out of this as is positive. Maybe you have just ignited a few entrepreneurs to think about all of what you just said and use Web3 and blockchain technology to some extent in some use cases to address the issues that you just outlined and make it a more better, more privacy respected world. So with that, I would like to open the floor to take maybe one or two questions, please. Sonia, do we have a question? If we don't,
Hi, Thomas. Yes, we do have one question. So using, and it's referencing everything that was discussed, using real data, such as harvested from Facebook and other social media platforms, is increasingly frowned upon due to privacy issues. What is your assessment of AI-generated synthetic data to be used by marketers for demand validation, price optimization, product innovation, and so on?
Sonia, thank you so much for relying this question. Thomas, thank you so much for a wonderful summary and inviting the questions. And thank you to the participant for asking it. It's a very important question. So there are a few issues here. First of all, in order to train those models to be able to simulate real human participants, they need to hover in real human data. So we have this chicken and egg problem here. And of course, we can say, well, let's just have data from 1,000 people or 10,000 people, and maybe that's enough. But the answer to it, well, yes, 10,000 people data should be enough. But if someone else comes up with their own AI model that is based on the data of 100 million people, this model is going to be even better. And corporations and governments will naturally push towards, better, more accurate products. So while I completely agree that those artificial participants are going to be much more widespread, those artificial participants are conceptually not different from a statistical model. Now, I'm studying large language models like ChatGPT-4. Now, those models, I argue, have their own psychological mechanisms. They have their own biases. Some of them they learn from humans, from the training data, but some other biases and some other mechanisms they develop spontaneously on their own as a kind of a phenomenon or byproduct of a model itself. But when you ask this model to behave like a participant or answer a questionnaire as if they were, a consumer for a particular product, what they're essentially doing, they're trying to model for you those particular consumers in the same way as our statistical models of the past, pre-AI statistical models, also tried to model a particular consumer. So yes, they're going to be used like this, but also it's not going to improve the privacy, because still a better model is the model that can continue harvesting and sucking in the data. So there'll be a huge motivation for people who train those models and use those models to essentially feed them with a lot of our information. And folks, this is not all bad. You know, I focus on the negatives here, but the fact that we can use our data to train the models, to can diagnose psychological disorders, diagnose medical disorders, help us to find good educational content, help us to find a good book, or maybe have a chat with us, like ChatGPT can give us advice, can teach us something. Those are tremendous benefits of those technologies. So the same technology that is creating those huge and, you know, unsolvable in some ways privacy risks, the same technology is providing us with enormous benefits. And this is why I actually honestly hope this technology is not going away, because we're just all benefiting from it, and especially those underprivileged ones and people who did not have access to human psychiatrist or a therapist, people who struggle to pay for a visit with a doctor or do not have a doctor in their community. Those folks, you know, I can go to a real doctor. I don't need to ask ChatGPT for medical advice. But there are literally billions of people in the world that do not have this tremendous privilege. And for them, those technologies that are fed on our data, on the data of medical doctors and my medical records, those are technologies that can be literally life-saving. This is why I hope that the actual takeaway from my talk will be, let's not shut down Facebook and those models. Let's just make our world more safe to people regardless of whether someone invaded their privacy or not. Let's create a legal and social norm that, as you say, create a situation when we frown upon our privacy being invaded and our data being shared publicly, and yet at the same time enable companies like the companies that you hopefully will build in the future to build wonderful, life-changing and society-changing models based on the same data.
Michal, I think with what you just said, I cannot have closed this session in a better way than actually what you just did. So I thank you again, and I will openly here re-invite you to any future sessions. Again, I'm speechless. I learned a lot. You make me think, and I hope you made other people think to look into this, addressing the issue, and make it a safer and better world for all of us. So with that, Michal, thank you very much.
Thank you so much for having me.